Hey folks, first video of 2021. Today, I was watching a YouTube channel on top 10 misunderstood disasters. Don't ask me how I found that channel. I'm a YouTube junkie. I like to learn things, like to understand things, like to study them. Top 10 disasters that are misunderstood. Okay. Today, I'm going to talk about the Exxon Valdez disaster. And that was a super oil tanker in 1989 that struck a reef off the coast of Alaska, resulting in almost 11 million gallons of oil being spilled in the Prince William Sound, or just off the coast of Alaska. It was the second worst oil disaster in history. Number one is the Deepwater Horizon oil platform a few years later. The Exxon Valdez caused massive environmental damage, killing wildlife, lots of cleanup involved. Total impact to Exxon, if you're just looking at the financials, right at $7 billion. So major impact. It's been over 30 years. Why did it occur? You may have heard things. Wasn't the captain drunk on that? You may have heard, boy, they just didn't have a double hull design, single hull design. So when you damaged the outside hull, it leaked into the environment. You may have heard it was a crew error. Last thing you may be thinking today is, Joe, what's this have to do with reliability? So I'll get into that in a second here. This is Joe Kuhn of Lean-Driven Reliability, bridging the gap between best practices that you should be doing. You understand the definitions, you understand the textbook approach, but you can't figure out how to drive culture change at your plant. And that's where Joe comes in here. Okay, let's get into this real life experience, okay? Yes, the captain was not on the bridge the night before. He was drinking, but he's not required to be on deck. And he was not, he was originally fired, but he's, was found to be innocent, and he was not intoxicated at the time of the incident. So that was the initial reaction by management: fire the person for making a bad decision. It's not the captain's fault. Number two, yes, it was a single hull design, but that was common at the time. They did pass laws in 1990 that said over the next 25 years you need to convert all of your ships to this double hull design. Great engineering change, but long time to implement. Wasn't the root cause of the disaster. Helps for future ones, minimize them. Number three, crew error. There was ice that required the ship, the Exxon Valdez, to go out of normal shipping lanes and force the third mate. It was their job to calculate the new route. This person did calculate a new route, but there was a staffing change by management to reduce the crew size. So this third mate calculated the new route, and he verified that his calculations were correct. So he calculated it and was verifying it, and you folks know that's a big penalty. You're not going to see your own mistakes. Think about lockout, tag out. You have somebody else verify that you did it correctly, not do it yourself. That's a big problem. He actually made an error, and he checked himself and didn't catch his error. That's asking too much out of a human being to check for their own errors and be able to catch that. Think about, I know when I published my book and had it edited, I paid somebody externally to edit that book because I couldn't see the obvious errors to somebody else, okay? That's why you design in an external check. Big error due to management wanting to cut cost. It wasn't a bad idea to reduce the size of the crew, but didn't understand what the different crew members were doing and the value that they brought at the time. Number four reason this happened is looking at the ship's radar, or the collision avoidance system was broken for over a year. Management knew it, thought it cost too much to repair it. So their collision prevention system, just in case there is an error in the calculations that somebody may make, your backup system didn't work. That's just crazy. Everybody knew it. That was just a fatal mistake number 2. So they didn't have the radar fixed and operational, and then made a crew sizing change. Those were the 2 major contributors. It did not have anything to do with the single hull design, which helps in the future, and it had nothing to do with the captain. So cost-cutting efforts by management, without understanding current state, they didn't understand the checks and balances that go on the deck of a ship, resulted in this major disaster. Cost-cutting, folks, I talk about it a lot. It increases risk. Only increases risk, okay? And what's worse is you have no idea the risk you're taking. You're guessing. You're just guessing. The crew changes may be appropriate. I don't know how many, if they had 9 people and they went down to 7, I don't know that that's not a bad management call, but they didn't understand current state and who was checking who, who was fatigued, who was capable, had the skills to do a job, who was trained. They just cut the roles and said, you do both. Just crazy. And not having the technology working that was there to airproof the system. How many times have you at your plant, if you're a plant manager, how many times have you told your maintenance people your budget's going to be cut 10% next year, just figure it out? That's your job to figure it out. You're driving cost cutting, increasing risk, unless you have a system for reducing cost without increasing risk. And what is that? What is that approach? Every reliability tool, folks, is designed to target waste. Every reliability tool, I've gone into that several times. Why do you do PMs? Well, you want to maintain the equipment uptime. You want to maintain the performance of the of quality. You want to maintain the equipment life cycle, okay? Every reliability tool, think about it, is designed to eliminate waste. Take mean time between failure. Take it out longer, okay? When you look at waste elimination, your costs go down, and your reliability goes up, and your risk goes down. Your risk goes down. With cost cutting, your risk goes up some amount. You have no idea how much. With waste elimination, your costs go down, your reliability goes up, and your risk go down a known amount. All this comes from knowing current state. On this Exxon Valdez, you think anyone observed what was happening on the deck of this ship? What happened, how decisions were made, what equipment was in what working order? Do you think anybody sat there and analyzed that system and looked at it? No. KPIs, opinion, experience, all that stuff matters, folks, but it's not a substitute for knowing reality. Okay, how do you know reality? You know reality by knowing current state intimately through chalk circle observation. Chalk circle observation, here's your question. You get this a lot on my channel. When was the last time you as a leader, a maintenance leader, a reliability engineer, a plant manager, an ops manager, when was the last time you spent 8 hours on the shop floor looking at one of your critical reliability issues in your plant? If it's a cold rolling mill, when was the last, and was the exit end equipment that causes you all the issues? When was the last time you stood there for 8 hours and watched reality of what happened on the exit end? Just focused on what waste you see happening on that day. When was the last time you did that? I've never gotten an answer above 0 times, okay? It's always 0. And it's critical to your future. So what's the most popular, last question here, what's the most popular R&M strategic plan by management? The most popular strategic plan for R&M. You got it. Cost cutting. Look what happened to the Exxon Valdez. You're better than this, folks. It's 2021. There is a solution. It's waste focused by understanding current state. Solutions present themselves. This is not complex at all. This is very easy. You just you just can't be lazy, and you can't be frustrated and say just cut cost. There is a solution to this. Folks, begin your journey. If this is complicated to you, give me a call, send me an email. It is not complicated. Reliability and maintenance is not complicated. You just need to understand that it's targeting waste, and you got to understand your waste through observation, KPIs, and experience. It's not hard at all, okay? If I can help you out, give me a call, give me an email, send me a comment. I respond to 100% of them. This is Joe out.